Hi students, Mrs. Keller here with a video about graphing the cosine function. Let's start off by reminding ourselves about the sine function. So if we'll look here, we see a nice sine curve. Recall that sine is always the y coordinate if you're looking at those coordinates around the unit circle. To just quickly sketch a graph, you start and end on the midline. Halfway through, you cross the midline. Halfway between the first 2 points, you reach the maximum, and halfway between the last 2 points, you reach the minimum. So it's our basic sine curve. Cosine is going to be very similar. So let's take a look at cosine. Now, recall that cosine is always going to be the x coordinate as you're looking at the unit circle. So let's go ahead and just start here at 0 radians. The x coordinate is 1. So instead of starting here at 0, 0, we're actually going to start at 0, 1. And that is our first point. And then as we move around the unit circle, we could fill in every single one of these points, but we're just going to stick to the 5 basic points. So let's go all the way up here to pi over 2, or half of a pi. Our x value is now 0. So here at pi over 2, we're actually going to be at 0. Moving along to pi radians, the x value is -1. So here at pi, we're going to come all the way down to our minimum. As we continue around, 3 pi over 2, the x value is back to 0. So we'll graph a point right there. And then when we finish our cycle and we're back at 2 pi, our x value is back up at 1 at the maximum. So let's go ahead and fill in that curve. So you'll see it looks very similar to the sine curve, but instead we start and end at the maximum. Halfway in between, we reach the minimum, and halfway between each of those points, we cross it through the middle. So it's similar but different. Let's go ahead and show that on here. So we start at 0 and then our maximum. Oh yeah, recall, amplitude is 1 because there's no value here in front of the cosine, and the period length is 2 pi because we don't have any value here in front of our theta. So this is the standard amplitude and period with no other transformations. So we'll start here at 0, 1. We go 1 complete cycle away, the full period length of 2 pi, and we're going to be at the maximum again. Now we just play that game of halves, halfway between the minimum, in this case -1, then halfway between the first two, cross the midline, halfway between the second two, cross the midline, sketch that curve. Let's graph one in the negative direction. So starting here at -2 pi, we start here at the maximum, end here at 0 and the maximum, halfway, minimum, halfway across, and sketch the curve. So here is 2 complete cycles of the cosine curve. Now you might be curious to know what that looks like compared to sine. So here I have them side by side. So the blue graph is the cosine graph that we just graphed, and the red is the sine that we did last week. So you'll notice they are very, very similar. It's just as if one has been shifted over slightly. Notice here, sine starts and ends on the midline, halfway crosses the midline, halfway between maximum, halfway between minimum. So it's just, we can still play that same game of halves to get those 5 main points that we need to graph. It's just going to be a slightly different way of looking at it. So here's our basic cosine graph with the amplitude of 1 and a period of 2 pi. What happens now if I put a 3 in front of here? Well, you might say it's going to do the exact same thing that sine did. So this 3 right here creates an amplitude of 3. The period is still 2 pi because we haven't put anything in front of this theta. So now, instead of starting at 0, 1, we're going to start our graph at 0, 3, because the amplitude away from our midline is 3 units instead of 1 unit. Our period length is 2 pi, so we're going to go a full period away and up to the maximum again. Halfway in between these, we would reach our minimum, but instead of -1, because that amplitude is 3, I'm going to go all the way down to -3. In between our maximums and minimums, we always still cross that midline. So here and here, sketch the curve. And you'll see that that is a vertical stretch by a factor of 3. Going in the opposite direction, we'll start at -2 pi, Up here at the maximum, we end at the maximum. Halfway, we hit the minimum. Halfway, we cross. Halfway, we cross. And we'll sketch that curve. So you notice that this function, y equals 3 cosine of theta, is basically just stretched vertically 3 units taller than it was before in both directions, away from that midline. All right, what if we put a value here in front of the theta? It's going to do the same thing that happened with the sine function. So instead of an amplitude of 1 and a period of 2 pi, our amplitude is going to be 1 still, but now the period is going to be just pi. Because if you recall, the period is always 2 pi divided by b, whatever this value is here. So 2 pi divided by 2 is just pi. So let's graph. We'll start at 0 and our maximum, 1. Now we go the full period length away. So because our period is now pi, we're going to stop here at pi and hit the maximum. Halfway, we hit the minimum, -1. Halfway between these, we cross. Halfway between these, we cross and sketch that curve. If we go one in the negative direction, we're going to go exactly pi away, start at the maximum, end at the maximum, halfway, minimum, halfway cross, and sketch the curve. So you'll notice that that period length has been shrunk basically horizontally. Instead of fitting only one complete cycle within 2 pi, if I were to continue this on, I would create exactly 2 complete cycles from 0 to 2 pi. Now in negative, it's going to do the exact same thing that the negative sine function did. We're just starting with cosine instead. So our amplitude is still 1. The period length is still 2 pi, but this negative is going to cause a vertical reflection. So this graph is going to be completely reflected vertically over the x-axis. So instead of starting at 0 and the maximum, this time we start at 0 and the minimum. We'll end at 0 and the minimum. Halfway, we're going to hit our maximum this time, and then halfway we'll still cross that midline. And so that is our curve. Going in the negative direction, we'll start at the minimum, end at the minimum. Halfway, we'll reach our maximum. Halfway between each of those, we cross that midline and sketch the curve. So you'll notice here that this graph has just simply been reflected over the x-axis, that vertical reflection. All right, so what if we have all 3 transformations all happening here? So let's take a look at what's happening. I've got a negative, so that's going to tell me my graph's going to be reflected. I have 3 halves in front of the cosine. So this is going to tell me my amplitude, which is going to be 1.5. And then I have a 2 here in front of the theta, which means there's 2 cycles in 2 pi, or the period length is pi. So let's put all of that information here. All right, so I would normally start a cosine graph at 0 and then the maximum. But because it's reflected, I'm starting at 0 and the minimum, which is going to be -3 halves or -1.5. And now I'm going to think my period length is exactly pi, so I'm going to go pi units away. I'm going to be at the minimum again. And then I'm going to play the game of halves. Halfway between these two, I will hit the maximum, which is going to be a +1.5. Halfway between those, I'll cross the midline. Halfway between those, cross the midline, sketch that curve. And now let's do one in the negative direction. So I'm going to go exactly pi units backwards. And I'm going to go down because it's reflected, start at that minimum, end at the minimum, play the game of halves again. Halfway between, maximum, halfway between, cross, halfway between, cross, and sketch the curve. So I hope this will help you graph the cosine function, and I'll see you next time.